regression of multiple time series regressed on one another, right? Let's say there are two time series, one represented by the variable yt and the other represented by the variable xt. The yt represents the dependent variable in the combined regression and the xt represents the independent variable. Okay. So to understand whether this regression is possible at all or not, the first thing that we have to do is we have to test separately both yt and xt whether they have unit roots or not. So yt and xt, we do a unit root test like a Dickey-Fuller test. Right? Now in this test there are few possibilities that may come out. Let's check each of them. Case 1. Neither yt nor xt have unit root. Neither yt nor xt have unit root. In that case, regression is possible. Case 2. Yt has unit root. Xt does not. In this case, friends, regression is not possible. Why? Because firstly, many of the linear regression assumptions might be broken. And secondly, the regression will be non-covariant stationary. So for these two reasons, regression will not be advised or possible. Case 3. Yt does not have unit root, but xt does. In this case also, friends, regression will be not possible because of the similar reasons that linear regression assumptions will be broken and regression will not be covariant stationary. So here also regression is not possible. Case 4. Both xt and yt have unit roots. So friends, in this case there is some ambiguity. We have to check for one more factor which is called the co-integration factor for xt and yt. So what do we mean by co-integration, friends? Co-integration basically means whether xt and yt have a strong fundamental economic relationship between them, and whether they do not move out of bound with respect to each other in the long term, which simply means their values do not digress in the long term. So if there is an a strong economic relationship between xt and yt, and if their values do not digress from each other in the long term, that means they are co-integrated, right? Now how do we do a statistical test for checking whether they are co-integrated or not? Let's have a look at that. So friends, we have already said that xt and yt are going to be regressed upon each other, where yt is the dependent variable and xt is the independent variable. So we can write this kind of an equation: yt is equal to b0 plus b1 into xt plus some error value epsilon, right? Now this equation is going to be a starting point for checking whether there is co-integration or not. So friends, this test is also called a unit root test. So unit root test means what we will do? We will subtract xt from both sides. This will become b1 minus 1 multiplied by xt, because we have subtracted xt from both sides, plus epsilon. Now we will say that this b1 minus 1, we'll call it, let's say, g. So this equation becomes yt minus xt is equal to b0 plus g multiplied by xt plus epsilon, right? Now we will test for whether g is equal to 0 or not. Now this is our null hypothesis, friends. So friends, how do we test for it? As we already know, we do a t-statistic test. Now for unit roots, we usually have used the Dickey-Fuller t-table, right? These are different values from normal statistical t values, right? These critical values are different. Now we will use something further different. That is something called the Angel-Grainer corrected t values or tree critical values. So what Angel and Grainer have done is they have further corrected the Dickey-Fuller t critical values to account for the uncertainties that arise in the parameters when we are doing a regression on the time series, right? So they have done further corrections. So what we are going to use? We are going to use the t critical values of Angel-Grainer upon the Dickey-Fuller values. These values we are going to use for comparison. And comparing with this, if the t critical remains greater than the t value estimated, then we conclude that there is no unit root. And the second is, if t critical is less than the t value calculated, that means there is unit root. If there is unit root, that means co-integration is not there. And if there is no unit root, that means there is co-integration. So if there is no unit root, that means there is co-integration, which means regression is possible. And obviously if there is unit root, that means regression is not possible. So friends, one more thing we have to note about these integration and non-integration condition is that if there is co-integration, that also means that the model is covariance stationary. Right? It is covariance stationary also because G is not equal to 0. Right? And if there is no co-integration, that means G is equal to 0, which means the model is also non-covariance stationary. So this is one notable fact that we must remember. Now next what we'll do is we'll move into the steps of creating a time series model.